Okay, so we're going to cover the ATT, which is Assen's Air Tightness Tester, which is basically indicative high volume testing of small apartments or small spaces. All right, Cathal, so this is my garage. I know this is pretty airtight. We tested it around about 6 years ago. Now we've got the ATT here. It's got a nice little package. Can you show us through it?
Yeah, it's a great package. It's all self-contained. We have this pressure vessel. It's got an internal manometer. It's wireless. We've got a tablet we'll connect to. And we've got some charging and cables. We'll leave it in the packaging.
Yep.
That just keeps it all nice and no big changes in temperature. It's going to affect pressure.
So basically this is a little capsule that is going to capture our current pressure that we have inside my garage. And this is why it's critical that it's sort of insulated and not left on the floor directly when you're doing your testing.
Yeah, and we don't have to run any reference tubes to the outside. We can just shut the external doors, push the button there, and it'll start recording pressure.
So one thing I'd like to probably, just to put things into perspective here, this is a high volume tester. It's not something that you're gonna accurately test or is gonna be as accurate as a blower door testing equipment. It's predominantly for high volume tests to find outliers of poor performing or really ridiculous performing structures.
Okay, John, let's see how it works. Let's have a go. So you do have to open the door for this to equalize with the pressure outside. Our door is open, so we'll just turn it on now. And it's flashing red. It's doing its thing. It's recording the pressure outside. So now it's blue, flashing blue. It's trying to find a connection. So we'll connect the device with this Android tablet and it's connected to the ATT. All right, we're connected. We can start
So now
measuring.
we've got a blue light.
Yeah.
Before we actually did this, we had to capture the exact pressure that our exhaust system or fan system is exerting, how much airflow it's pushing into here. So that's something that you have to definitely plug in, including the volume and surface areas of the enclosure. That all goes into the software prior to a test. So the ATT actually requires quite accurate flow readings for the exhaust system that you're using to pressurize the house to get the air tightness test. Just being out by 5 or 10% can make a pretty big difference on what leakage rate you get from the ATT. So it's critical to use Assen's Flow Finder as well. This actually has a little motor in it. It neutralizes the pressure inside the flow hood, so it gets a way more accurate reading on how much air your exhaust system is actually moving. The idea of this is that you stick it in over the exhaust system and then you press a button here and it'll start stabilizing and creating pressure neutralization inside the enclosure that's connected to the exhaust fan, and this will give you the flow reading.
Just like a normal blower door test, you need to know your surface area, you need to know your volume to work out your ACH, air changes an hour, permeability. In addition to that, with the ATT, you must measure the flow rate of your exhaust fan, your ventilation system, where with a normal standard blower door setup, that's measuring the fan speed from the blower door itself and ignores your exhaust system. You don't record that, you turn that off.
Now, I guess the other thing that we're going to be testing here, which the blower door is going to be testing as well, is the door that you'd normally set a blower door onto.
That's right, yeah. With the blower door setup, it ignores your external door because you've opened that up and you've filled it in with a blower door. So in theory, you seal that 100% airtight, which is not recording if there is any leaks with your external door, which there may be. So we have blue light.
Yep.
Start measurements.
Connected.
Okay. All right, we started. So now we have the door open. We can shut the door and switch the fan on.
So in an apartment setting, you'd be able to use the slider, I guess, to get outside pressure.
So what we're looking at here, John, is now that the apartment pressure, or the garage, your man cave, has been pressurized, we see the graph record that, and we're waiting for a blue dot, which the app's going to tell us got enough information. We've got the blue dot now, so you can switch the fan off, and we can see the pressure drop. We'll do this 5 times, And then we get a delta P. It's able to extrapolate from that a permeability or an ACH.
So now we're waiting on another dot.
Yes, we're waiting on a green dot. We've got pressure here on the y-axis, time on the x-axis. Got the green dot now, John. You can switch the fan or your ventilation system back on.
Mm-hmm.
Okay, we see the pressure rise. And again, we're waiting for that blue dot. Okay, blue dot. You can switch the ventilation off. So we're waiting for the green dot. You see all the pressure drop. Green dot, so you can switch it back on. Again, pressure's rising. Waiting for a blue dot to confirm it's received enough data. So the pressure's rising. We have a manometer set up here so we can actually record the pressure between outside and inside. You don't need this. This is separate, but we just want to see what's going on. So we're now at 50 pascals. According to the ATT, we're just above 60 pascals. But the ATT tester works a bit different. We've got a blue dot. The reference of pressure in that vessel has changed since we first recorded, and it's compensating for that.
Is that the last one?
That's the last one. So we've got 5 readings now. We should be able to extrapolate a result from this. We'll just wait for a green dot.
Yep.
And I'll end the test. Oh, we got green dot. Can end measurement. Well, let's see what we got. Well, it's airtight. It's at 10 PA, so I'll need to change that.
Mm-hmm.
So we got a permeability at 2.1
Yeah.
meters cubed an hour per meter square.
Cool.
It's flow through our
Yeah,
fabric,
it's in the
building
ballpark.
fabric. We can change that to ACH.
Yeah.
The 2 readings. 2.8 ACH.
Cool.
Which is not as good as a blower door. It's a bit worse than the blower door result.
Mm-hmm.
But the blower door we know is more accurate, and we can fault find with a blower door using smoke and using our hand. But the air tightness tester is faster.
Oh yeah.
And that's why I was about doing volume, doing a lot of units
Yep.
in a day, and finding out where the problems are, where you can bring a blower door in
Mm-hmm.
and diagnose where things are going wrong.